Okay, so we got a question regarding trigonometric identities followed up by integration. In part 1, it says prove the identity tan 2 theta minus tan theta is identical to tan theta sec 2 theta. So I'm going to prove this using the left hand side by simplifying the left hand side. So if you look at it, my left hand side says tan 2 theta minus tan theta. In order to obtain sec 2 theta, I will have to use the double angle formula to expand tan 2 theta, which I have done here. 2 tan theta minus 1 minus tan square theta and minus tan theta. So over here we can say by taking the LCM, it's 2 tan theta minus tan theta into 1 minus tan square theta over 1 minus tan square theta. And what I did was I have taken tan theta as a common factor out and then simplified this, which will give me tan theta into sec square theta into 1 minus tan square theta. If you look at the answer, we already have tan theta there, and only thing is missing is sec 2 theta, which I would be trying to simplify by using sec square theta over 1 minus tan square theta. So since we got sec square theta as well as tan square theta, I have converted my sec square theta into 1 over cos square theta, which is the definition, and 1 minus tan square theta I have been written here as sin square theta over cos square theta 1 minus. So and then what I did was I multiplied numerator and denominator both by cos square theta so that it can simplify into 1 over cos square theta into cos square theta is 1, and cos square theta into 1 is cos square theta, and cos square theta into tan square theta gives you sin square theta. Now cos square theta minus sin square theta is actually the double angle formula for cos theta, which is cos 2 theta. So that is 1 over cos 2 theta is actually sec 2 theta. So this gives me the right hand side. So that is the working for part 1. And then they say hence show that integral of 0 to pi by 6 tan theta sec 2 theta d theta is equal to half ln 3 by 2. In other words, they wanted to integrate the right hand side and show that it is equal to half ln 3 by 2. So here I've started with the given integral. Since we have already used proved the identity, I can use the left hand side of the identity instead of the right hand side, which is integral of 0 to pi by 6 tan 2 theta minus tan theta. And now if you look at tan 2 theta and tan theta is actually sin 2 theta over cos 2 theta, sin theta over cos theta. Now I would like to recall a theory behind this. If you consider y equals, this is because some of you might not be familiar with the integral method I'm using here. It's called the standard integral patterns, and y is equal to ln fx. If you differentiate this with respect to x, if you differentiate this with respect to x, it would be 1 over fx because ln function into 1 multiplied by f dash x. In fact, it is f dash x over fx. So I'm trying to do the same thing here. Y is a function of theta. Y is equal to sec 2 theta. If I differentiate that, it will give me my fx is sec 2 theta. So 1 over sec 2 theta is there in the denominator. And when I differentiate this, it becomes sec 2 theta tan 2 theta into 2. So that is what I have got here. So this simplifies into dy by d theta equals 2 tan 2 theta. Now if I go in reverse and integrate this, I will get half dy is equal to tan 2 theta d theta, which can be integrated. So this result is what I have used here to get this. So integral of dy is actually half ln sec 2 theta. So that's been used here, and my integral of tan theta is equal to ln sec theta. So that gives I equals to, I is what I had to find here, which I have defined, and I is equal to half ln sec 2 theta minus ln sec theta with the limits. So we can use the laws of logarithms, which is applicable to ln functions as well. This half over here I have represented using the square root, and then because of this minus, I have used the laws of logarithms to bring it down to a single logarithm. Now that I can substitute my values, pi by 6 into 2 becomes pi by 3. That's why you can see we get this value and this value over here as well. And sec pi by 3, since cos pi by 3 is half, sec pi by 3 is 2, and since of this, because of the square root, it's root 2, and sec pi by 6 becomes this value. So this will simplify, and what I did was I wanted to make it a common square root, so I wrote 2 as inside the square root 2 into 2. So these 2 cancels off and gives you ln root 3 by 2. So the root can be brought back down as half. So we finally get the answer, which is half ln 3 by 2, which is given here. So hope you understood the question.